So we'll start with some demystifying about data science, since everyone seems to think it may be a complex topic. So we will start by trying to define what data science is. And the best way that I found to define it was to actually go to pages built by data scientists and try to find out what they think about themselves and what they do. So the first thing we will check at is a definition by data scientists. So as you can see, they say there are someone who does precision guesswork based on unreliable data provided by those of questionable knowledge. You can also check wizard and magician. The second definition that I found interesting was this one, on how people perceive data scientists, depending on who you ask. If you ask their friends, if you ask their moms, if you ask their boss, if you ask them what they think they do and what they think they actually do. So it ranges from really complex things, science fiction stuff, to just typing some code in the computer. And of course, among all the humor that you can see here, there are some parts of truth in this, and we will see that as long as we go in the presentation. Data scientists a lot of time have to work with unreliable data, with people that don't know exactly what data to provide, and they have to do a lot of precision guesswork. So these things, even though in a funny way, they're not that far from the actual truth on what data scientists do. And as you can see, data science can be fun as well. So moving to a more precise definition of data science, we can say it's a field that uses scientific methods and processes to get insights from structured and unstructured data. It's very related to data mining, machine learning, etc. I don't like this definition a lot. It's not a friendly definition. I found one that helps paint a better idea, that says that data science is actually more about data than it is about science. If you have the data, if you have curiosity to work with the data, if you start manipulating it, you're exploring it, then you're starting to do data science. And that's the main idea that I want to bring you today. You don't have to be a scientist to start working with this. You don't have to have full qualifications. The first thing you have to have is the interest to go into data science and start learning in that field. It's easier than you think. It has a very good learning curve. So I encourage you, if you haven't started thinking about learning data science, please do, and I hope that this presentation helps you take that decision moving forward. So why does this data science field matter today in the WFM world? Well, as you all probably know, WFM organizations today, we deal with large amounts of data. The business is getting more complex and complex, its size is growing. Everyone that's worked, as I do as an example, in strategic outsourcing knows perfectly well that we live in a VUCA environment today. And different to other disciplines, WFM scope is human beings. And human beings are not just products. Human beings evolve over time. They get new skills, they get new experience. Companies need different things from them. We're not dealing with just a simple product that stays the same all along the cycle till it's produced, until it's sold. But we're dealing with people that learns new stuff, has interests, and wants to do different things. So in that field, the traditional solutions may not work, and we need to adapt to that. And that is where data science can help us a lot to do that adaptation. More and more today, we have information not only from our structured databases that we build, we also get more and more unstructured data. We can deal with the sentiment of people, comments, and we can quantify them, analyze them, get meaningful data out of that. And that's another matter where data science is doing a lot to advance the research and get you meaningful insights for that. Another good point is data privacy concerns are growing in all nations. If you go to Europe, you have GDPR. It's a leading legislation, but across the world, you're seeing data is more and more being protected. So when you deal with data, it's very important that you understand how to take care of it, how to analyze it without breaching those legislations, because that can bring some issues to your company. So you need to be careful with how you deal with data, and data science and its methods help you work in the correct way with it. So basically, as you can see, WFM organizations today need to start understanding data science if they haven't already embraced it, because it will help them bring better insights, ensure that data is treated in the optimal way, and they can provide these insights to their clients. Not as much as in Dilbert's case, where, as you can see, if you treat it in an unprofessional way, you can get any results from data, but they won't be a real insight. Now, this is why data science matters to WFM organizations, but what about yourselves? If you haven't considered learning data science, WFM practitioners today, after the pandemic, have a lot of focus to achieve several things. To deal with our organizations, as I said, we're dealing in a VUCA environment, very complex and certain. We need to be agile, we need to adapt, we need to understand our organization better, we need to keep learning all the time. And this goes not just for our WFM work, it needs to be a mindset for us all the time to keep learning new things that may help us do our works better and grow as persons. So, and the most important part of this is we need to make sure that we as WFM, we are advisors to business. We influence the right persons to take the right decisions. And the good part is data science can help you achieve all of these. So when you understand data science, understand these tools, they will enable to actually provide meaningful insights, provide meaningful visualizations that can be understood by people that doesn't understand data science, and they can take the right decisions with you. But if these reasons were not enough, there's another extra reason, which is data scientists get paid very well. So it's really interesting if you're going into this field, data scientists get very good salaries. So that's another reason why you may consider data science and understanding how it can add to your current skill set in your WFM organization. Now, what I will do is I will show you a couple examples on how data science and its tools can be applied to the day-to-day business work that you have. And I will share a couple personal examples so we can see that. So the first example that I have to share is, as I mentioned, I work in GTS in IBM. That's a strategic outsourcing organization. We have a lot of people working in GTS today. It's about 100,000 people, and they range for a lot of different skill sets. It's about more than 700 different skills that we deal with in these outsourcing organizations. So as you can imagine, we have a lot of different offerings that we do for our clients, and they need different skills. Now, in the strategic outsourcing world, skills are not static. You don't just learn something and do that for the next 30 years, but you actually need to provide new services, new technologies come in, and you need new skills to understand what to provide to your clients. So one of the needs we saw we had many years ago was that we don't have, or we didn't have at the time, from any out-of-the-box tool, any insight that could tell us, okay, so this is the situation today on your population, the skills they have, and what skills you will need into the future. So we know what we need today, but when you start looking forward into the future, it's more and more difficult to create some model that can tell you we need this specific set of skills, we don't have them today, so we need to start taking actions on them. Or we have this other set of skills that we have today, and it won't be needed in the near future. So how can we retrain these people to take on the new skills that we need? And that, as you can imagine, I'm talking tens of thousands of people and around 700 different skills and thousands of clients and deals. So how do you process all that data? We found no out-of-the-box tool that could do that, but that was a real need. So we started analyzing what different data structures we had at our hand and started analyzing and creating a solution based on data science. So what we did was created an engine in Python that tapped on all the data, on the possible data sources that could help us understand this. So we tapped into what our current headcount skills are, what are the requests we have today open, what are the offerings we do and how we allocate the people to those offerings, what are our future deals that are coming in the pipeline to understand what kind of skills we will need, what are the attrition projections we have, what's the forecasted productivity, what accounts will exit the company because of their contract termination, and so on and so forth, and more databases as well. So we tapped on all those data structure, and with Python engine that we built, we created a solution that provides personalized outputs for the different stakeholders that need to check at that. And it does that in an automated way. So now, today, we can easily say, by the type of skills, by our business models, by our types of offerings or service lines, what skills we have today, what skills we will need in the future, based on all those kinds of structured and unstructured data that we have, and that the model predicts we will be needing, so we can start take action early and training the people to understand how it works. So where there was no solution, data science helped build one that keeps getting improved all the time. Its outputs, we revise them every week, as a matter of fact, and we keep improving the results by the model to make sure it stays relevant. So this is one good case of practical applications of data science. The other one I can share has to do with a different approach, where one of the areas that usually creates some concerns is about hiring people. Hiring people is always an area where you need to seek approvals, and sometimes it can get delayed. So what we were asked to do was to analyze how we could make our hiring approval flow faster within the process we had. So we started to work again with a data science solution to understand if we could get any meaningful insights that we could help on that. As I mentioned before, in this case, again, no out-of-the-box tool could provide us this data, so we had to build a flexible solution that could help us understand that. So what we did was understand the full flow of approvals that we have, and tapping again into the data that we have on that flow of approvals. So of course, since this runs in databases, we had already a lot of structured data that could help us identify patterns for where requests get delays. So we started drawing a picture with patterns. As you can see, an example of the methods we use. We use scatter plots to identify how most of the approvals are running a certain path, but then there are outliers that take longer time, and we started identifying the patterns on those. And we also tapped on a lot of unstructured data. So in this case, people that approve stuff is able to leave comments on why they approve or they don't approve. So we were dealing with a database of around 10,000 comments that would take a lot of time for just a single human being to read. So what we did was use NLP, natural language processing, to go over all this information and try to identify, again, patterns within the language that could point us to where we could find the reasons for the most common rejections and how we could address them. So with all of this analysis, we created a set of definitions and recommendations for the owners of the process to tell them, okay, so here are the areas where we find patterns that create delays. This is how you can, this is where you should focus to address them. So as you can see, data science helps you to be flexible where your current tools may not help, and address needs that perhaps you didn't know were there, but you can create new solutions that help you take on those needs. And these are just two cases that I experienced. There are a lot of more that we could go over. So how did we approach these cases is how actually data science works. So when taking a problem and approaching it with data science methodology on a high level, what you will do is first you will create the idea of the problem. You will form the concrete problem and analyze what you want to solve. In the example I gave, the first example was we wanted to have a clear picture on what skills we will need into the future. That's the problem we need to solve. Once you have that problem laid out, what you do next is you start collecting and analyzing the data. And this is a big part of the data science work, because you will hear a lot about machine learning, AI, and a lot of advanced technologies, but data science at its most, it takes a lot of its work to determine what's the right data you need to collect, and because not all data is meaningful. And once you have the data, you need to understand that and prepare that. A lot of the data science work has to do with data cleaning and preparing the data to be analyzed. As I said in the beginning, many times we deal with unreliable data. Even on structured data, you will find there's lots of data points that are not right. People fill them wrong. If you have free text fields, those are usually nightmares for data scientists. So you will find there's a lot of work in preparing the data. It's a very important part of the data science work. Now, once you have that set of data, as we did, where we tapped a lot of different databases to get the different data points we needed, you start evaluating the data, analyzing the data, and you create a model. You create a model that analyzes the data and gives you the outputs you need. As in the example I was sharing before, you tap the data sources on what your current skills are, what deals you have in the future coming, what contracts are leaving, and so on. And with all those data points, you create a model, and then that model will tell you these are the future skills that you will need. These are the skills that a year from now you will need to have, so you need to start working. And that's what a model will usually tell you, that it will give you some output that you can take decisions on. But the work doesn't finish there. Once you deploy that model and you start taking the insights from it, and it may take several tries, you may try different models to analyze the data, but once you do, you choose one and you start running it, you need to understand the feedback once you deployed it. It's a very important part of data science. You don't finish your work just by creating the output. You need to keep validating the output and the feedback to make sure it stays relevant to your stakeholders. So once you get the outputs and you start checking with your stakeholders what the outputs mean to them, you are able to make the right adjustments to the model to keep making it more precise and more meaningful to your stakeholders. Now, all of these you're not able to do with just a pencil and a paper. You need tools to do this. It's and in the increasing complexity that we live in today, you need powerful tools to actually carry on these tasks. So we'll talk about them in the next section, but before I do, Shiva, I will get back to you for a second.
Yeah, sure, John. Yeah, before we move on, let's take a second poll question. Okay, what do you think it is important to bridge the gap between WFM and data science? Let's start voting. This is really very important question for all of us to know that we always, get to see either we should learn data science or, learn within WFM. So both are very important skill sets, and this is one of the questions that we thought that is very important to share it with the team. Can we have others to vote, please? All that you got to do is just look at the question again, and then select the right options and touch the button or click. Okay, so we're done. Let me share the. We're done with the poll, and let me publish the results. Okay. Great. Hope all of you are able to see it. John, are you able to see the screen?
Yeah, I can see it.
Okay, wonderful. So 39% of people say that data analytics improves the quality of decisions, whereas 43% of them say that WFM relies on the data. So data science is important. Analytics skills to be developed and data-driven knowledge, 15%, and none of them was very low. Great. All right. Thank you so much for taking your time and effort to vote for it. And before we move on, since we have one more question, John, I'll just take one more question while there, so that we have 5 questions totally, so that we will be able to engage everyone. Okay. And now, quickly, just have a third question. Okay, according to you, which is the best program to do statistical analysis? We have R program, SPSS, Python, Minitab. Great, 48%, 51. Wow, that's great. We're going, friends. Come on. Just close the poll now, and let me share the results. Wow, 30% of them say that R programming, just 5% SPSS, 50% Python. Wonderful. And Minitab just 16%. Thank you so much for all of you participating. We will have a few more questions coming through. So with this, we'll move forward with the presentation of Juan. Juan, over to you.
Okay, thank you, Shiva. Thank you for the poll. Actually, it's very relevant to my next topic, so we'll move into that. So, as I said, we will talk about what are the best tools to carry on with data science. But to start with that item, I will deviate a little bit and talk to you about carpentry. So, a long time ago, my father and I had a conversation where he wanted to build a wooden deck for his garden. He had a nice garden and he wanted to put a wooden deck. Now he started working on it and he put all the iron planks, iron railings that would form the structure of the wooden deck, but he needed to attach 50 wooden planks to those railings. And those planks each had 5 screws that you had to attach to the railing and drill the wooden plank. So the first thing we did when we started working on it was decide, okay, what's the best tool that we can use to drill on each of the wooden planks and help us carry on this task and do it in an efficient way. So we started analyzing the tools, and the first tool that we analyzed was the good old screwdriver. The screwdriver is cheap. We could buy 2 for a very low amount of money, but it would do the work. But the problem it had was if you had to drill through wood at hand with a screwdriver, it will take you a lot of time and a lot of effort. So you will take a lot of time to actually build the deck. And when you finish, you will for sure need a doctor for your arm because you will do a lot of effort with your arm to drill the screws. So we said, okay, this is not a good option for us to build a deck. So let's see what else is in the market. So we moved into an electric screwdriver. It had a small battery, so it's a home screwdriver that allows you to do small tasks. And this one was already better because you didn't have to do the effort with your arm, and it worked faster in drilling the wood than what we could do by hand. However, the battery took a lot of time to recharge, so and it didn't last very long. So it also took a lot of time to build the deck. So we said, okay, what else is in the market that we could use? And we looked for a professional screwdriver, and it was a little more costlier, as you can see, but it did the work very fast. You could drill the wood right away with the screw. It stayed in place, and it had a battery that could take on the whole work on the deck. So you could do that right away. And it took, if you see the times it would take for each of these tools, it was already a considerable saving of time that we would use with this tool. So we said, okay, we will go with this one. But since I'm a technology fan, I wondered, is there any other solution that we could use that could be better than this screwdriver? And there was. There's a robotic arm that has artificial intelligence that you could just plug to the electricity and it will do the work for you. Faster, better, and while it works, you can play with your kids in the garden. And a time later, you will get there and it will have already done the work. The big problem of this robotic arm, of course, is the cost. So we said, no way, we're going to pay that just to build a wooden deck. So we went with the professional screwdriver. Now, I'm telling you this anecdote because data science works in the same way as you could do carpentry. Using the right tool does make a difference, and you not always need the same tool. So if we want to take a view on what data science actually does offer with tools, you will see that if you want to make an analogy to the home screwdriver made for small tasks and small analysis, you will have the set of tools like Excel, OpenOffice, and so on. Those are tools that helps you do small tasks and process small amounts of data. Now, if you want to go with a more professional solution that will allow you for higher volumes and more flexibility and speed, you will now start talking about Python, Jupyter, R, NumPy, Pandas, tools that help you achieve processing high loads of data at a higher speed and with a lot more flexibility than Excel, as an example, could do. And if you want to have the robotic arm version of data science tools, then you will start moving to things like TensorFlow, Scala, Keras, PyTorch, tools that enable you to do machine learning and apply AI to your to the data you analyze, to the outputs you want to do. So as you can see, same thing as in carpentry, when working with data science, you need to use the right tools. Now, an interesting side of data science is that, opposite to what happens in carpentry, the more complex the tool and the more useful it gets, it actually has an impact on cost. So as you can see, if you wanted to use things for small projects like Excel, PowerPoint, and Word to build presentations, you would probably pay Microsoft some fee per month so you could use them and do your work. However, if you start moving to more powerful tools like Python, R, those come free for you to use. All the Python libraries, all the R libraries are mostly free to use, and you can use them without restrictions. So you're getting more powerful tools, more flexible tools for the cost of nothing. And interestingly enough, if you want to go and get to really complex stuff like machine learning, that's also free to use. You can just go and download PyTorch or TensorFlow, and it will cost you nothing. All it costs to use these tools is actually to learn them and learn how to use them. So the investment you do on learning then has no extra cost on using the tools. So it's a really important consideration when you start thinking of data science. Now, Shiva was doing a poll before on what the most popular data science languages are, and it's good to see that on that poll that we struck the right note, since I've already piled up some of those. So Excel needs no presentation. It will help you do data science work. Perhaps you don't see it right away as a data science tool, but it is. And it may be the right tool for a lot of work. It may not be the best tool for most of data science work, but you need to consider that Excel or any kind of spreadsheet as a data science tool, because it may help you achieve certain things in a simpler way. Then, of course, we have R. R is a very data science oriented program, and it's very oriented to statistical analysis and scientific and academic work. So it's one option. To me, it's not the best one, but it's also an option that you could use on data science. Then we have Python. Python is a programming language created in the 90s by Guido van Rossum, and it has grown year over year in popularity, and there's a reason for that. Python is extremely developer friendly. You can read Python almost as you read English, so it has a very smooth learning curve, and as it gets more popular, it gets more and more data science libraries that you can use to do the work. So when you do data science, you need to consider Python very much. Then, of course, it helps to be proficient in SQL. SQL connects you to the databases and is the interface within you and most databases. It also has a very straightforward language to learn that helps you with just 3 queries, select the right data from a lot of data you have in your databases. So it's another tool of choice for data science. Then you have Scala, and here we're going to higher level because Scala allows you to handle very large amounts of data that you won't do with your normal tools. But now we're talking about high performance data science. So this is just for you to know it exists as well. Then you have some other languages, but they're not the most traditionally viewed for data science. Now, if you're thinking, I'm interested in learning some data science language, I have a couple analyses I wanted to share with you and a couple recommendations from personal experience. You can, of course, and I encourage you to do your own investigation based on your own needs, so you can understand what's the best language for you. I will just share here some examples on what my personal learning was to determine what I would be better off learning. So right away, I started, I knew very much about Excel when I started the data science journey. So the next thing I said was, okay, I need to learn some other language for data science that helps me do more powerful stuff than what Excel allows. So right away, I was presented with the two most popular options, Python and R. And I started doing some research. So as I said, Python is very easy to learn, and that helped me into my decision. It has a really smooth learning curve. It starts really easy, and when you start programming in Python, you can do a lot of things right away. So all the times you're getting a sense of accomplishment because you're learning and doing more and more things as you go in the way. On the other hand, I also tried R. R is primarily used in academics and research, and as I said, and it's probably more statistically oriented. So for people like statisticians, engineers, scientists that don't have programming skills, it may be a more plug and play fit. So depending on what your background is and what you want to achieve, you may consider those things. These two tools today are getting a lot of support and a lot of libraries, so you can probably do similar things in them. It's a matter of choice on how you read data and how you are more comfortable with it. I did some more data science work to understand what would be best for me. So the next thing I did was move into Stack Overflow. Stack Overflow is a page that I really recommend for anyone trying to learn any language. If you're already working with a language, you're probably a frequent visitor of Stack Overflow. In there, you have people sharing their knowledge, people asking questions on how they do things, and sharing their knowledge on how to solve problems. So that's a page that I recommend. It also has a survey that it does year over year to all the developers to understand several things on the developers' likes and dislikes. And one thing they do is analyze the popularity of language. You can see here Python has a higher popularity over R in the programming languages, but they're both very, very popular. Another good source to understand how popular are programs is TIOBE. That's another page that month over month measures the popularity of programs. And popularity is important because the most popular programs are, the better support they get from the community. The more innovations they will get, the more libraries they will get, and more people will be able to answer your questions. So you may consider that on your choice. As you can see, Python is way more popular than R in either of those surveys, but both of them have very good support. So you need to understand what fits you most. In my case, what drove my decision was the kind of libraries that you could use. Pandas, to me, is really, really helpful. It's a library that helps you deal with Excel files and non-Excel data. It helps you do a lot of your data science work. So especially for the people that are beginning on the data science field, Pandas is a go-to library that you need to understand and work with. So those are some of the considerations I did when I started my journey in learning some tools on data science. Now, if you want to check all of them, as I said, they're free, so you can go to python.org and download Python and start playing right away with it. There's also a very good distribution of Python called Anaconda. Anaconda already has Python built in, but they also put together all the data science libraries that you can use. So it's a very good distribution for people that are focused on data science work. And I encourage you to try them all. They're all free, so you can try them. If you don't like them, you just delete them. Same thing with R. If you want to download R, you just go to rproject.org and you can download the R program and start working with it. So some final thoughts on how you should get started if you haven't already with data science. It has the same structure as we talked before. You define a problem. Define a problem. Once you do have the problem and you know what solution you would like, you start capturing data. You need to design the right structures for your data. Wrong data structures will lead to issues later, because usually we scale on solutions. So if we create a bad solution at the beginning, when scaling, it will be even worse. You archive your data, you don't overwrite it. Historical data tends to be really useful, so keep that in mind. Start small, starts with a small project. When I started with this, my first big problem that I had was I dealt with a lot of Excel files that I had to daily cut and paste to put them into one single Excel file. So at some point I thought, okay, there must be a faster way that I can do that, an automated way. So that's what got me into Python and Pandas. And I created a script that was probably 4 lines that could take the 15 Excel files that I process daily and put them one next to the other together in just 2 seconds against the long time that it took to me to do that by hand, or even with a VBA script. And most importantly of all, you need to create this interest for data science within your employees, if you have them, your peers. It won't help just having one person with the skills. It doesn't help to have the data scientist. You need to have as many people with the skill, because you can be an SME in other things and also have data science skills, and it will help you do your work better. So those are just some tips on how you should get started. So just a final couple advices. You need to think on what you really need. Try to be simple. Try not to do the most complicated solution. As Matt here said in the Twitter, most time when companies say they need AI, they just need a pivot with filtered data. So keep that in mind. Always try to do the right solution, the most simple one. Don't try to overhype what you're doing in data science. You need to go to the most simple solution that addresses your problem. If you need AI, of course, go ahead and do it, but think about it. Most of the time, it probably is not necessary. If it is, you will have a lot of paths to follow. So you could decide you need just to do some analysis on the data, or you need to do some statistics work, or you're dealing with lots of data and you need to take some decisions and advice, so you need machine learning. So there's a lot of different paths that you can follow. You need to think on what you need, and then you start applying those data science skills that you learn. So I'm hoping that this has been helpful for you. It's been really helpful for me, so I'm hoping that you get good insights from this. And if you haven't started, it helps you define your participation in the science adventure. It's very rewarding, and it gets fun when you start doing it. So thanks, everyone. And I think we have some time for questions. So back to you, Shiva.
Yeah, thanks, John, for a very insightful presentation. Great learning, and we will share the presentation to all the participants who have joined us here. Before we move on to the next, I'll request all the audience to, if you have any questions, you can raise your hand. I'll unmute you so that you'll be able to ask questions to John. All right, while we get other questions, let's have last question, last poll. which we will quickly take it up. This is very relevant to all of us. As which of the below are the most required skill set to learn data science in WFM? Mathematical knowledge, understanding the basic WFM functions, knowledge of R or Python, or all the above? Come on, can we have the voting, please? All you got to do is just click a button. Just closing the poll now. Let me share the result. Okay, 73% of them say that like all the above. Predominantly like mathematical knowledge, understanding the basics of functions of WFM and in hard Python and many other skill sets many other tools in WFM are very important.
And I couldn't agree more. That's the right answer to me.
Yeah, absolutely. And do we have any questions from anyone? Anyone would like to raise your hand? Nadeem Sheikh is not able to speak to us. I think some problem with his system. Okay, so before we move on, Juan, how much time you have now? You already have us up now?
I have a couple minutes more.
Okay, couple of minutes more. Okay, great. What I would do is I'll just share the kind of programs what GWFM is offering. In fact, this will talk about kind of offerings which GWFM has been into this and trying to get the real essence of it. And we're the first one to introduce this in the market. GWFM is introducing the course, which is already introduced, where we have the first batch coming up in the month of July 15th. So we're going to have at least around 25-30 people to start with in multiple batches. The certification is going to be from GWFM USA and Canada Chartered Body. And we have covered most of the essential part of data science required for the WFM folks. We have basic and also advanced, where basic itself is going to cover 60 hours of program. And advanced is going to be another 60 hours of program, which is going to be as good as you take a diploma or any PG program where you're going to learn hundreds of hours of data science in WFM. So most of us, we always struggle to have learning from data science tools and then try to replicate that. It becomes like most of the time it becomes like irrelevant, or like you may not get the opportunity to do that. But here in GWFM, what we are offering is you learn step-by-step process way, where we have the certification program, executive program, postgraduate program, okay, PGP, and then MBA and fellowship in data science in WFM. Any of you are interested, I can reach out to us and we'll be able to get back to you on this. With this, let me not take much time. Juan, thank you so much for taking your time out. Truly honored to have you, and great knowledge that you have shared it with us, and really appreciate your time taken. And this has been really great learning for me, and also like all the participants who have joined us here. And audience, thank you so much for taking your time out, for joining, and great effort from each one of you, spending time investing in learning about WFM and analytics, WFM in data science. All right, thank you so much.